ROI, the business case for adopting predictive maintenance practices. So today I'm going to go through 5 different types of benefits. So let's dive in. Today, you are managing a centrifugal pump. It's a reasonably large centrifugal pump located very low, in a subterraneous floor in your plant. And good for you, you know in advance when a bearing fails, and you get a note that you have an alert that you have a outer race flaw. Because you're using this predictive maintenance technology, you're able to carefully schedule that inside of your CMMS, procure the spare parts that you need, and implement the fix within 4 weeks, and you're back up and running. Life is good. So that's when life is good with predictive maintenance. Now let's do the other side. Let's say you haven't used any predictive maintenance technologies. We start back with that same initial flaw. You've got an outer race flaw in your bearing, but now, because you haven't caught it, you don't yet know that that's there, and it's going to get progressively worse. Soon the outer race flaw will cause enough damage to make a bearing ball flaw. So now your roller is damaged as well. And then the inner race will start to go. So overall, your bearing will degrade really significantly to the point where you'll start to experience a lot of heat generation inside the bearing, and you will require a lot more energy to power the pump overall because the bearing is not operating nearly as smoothly as it was before. So this is not good, but you don't know that this is happening. It's all happening invisibly inside of your machine. And now the bearing overall is exuding significant heat. The shaft of this pump does not like heat, because uneven heating on a shaft will cause it to bow. And if you've ever worked on centrifugal pumps, you know that there are tight fits and clearances all over the machine train, most notably between the volute and the impeller, but also between the wear ring that's on the casing and the wear ring that is on the impeller itself along the center ring. All of these fits and clearances are tight, and when your shaft begins to bow, you're highly likely to rub those different surfaces. That now causes another heat generation source that even worsens the bow that you're experiencing on your shaft. So things are getting progressively worse. The motor is having more and more difficulty actually powering the pump, and now it is heating up itself and is in danger of having some arcing across of the thin areas of your windings. So none of this is great. Everything continues to degrade. Finally, the motor is unable to turn the pump because of all of the rubs and all of the back pressure that it's getting, and you have a catastrophic failure of the pump where it seizes up completely. Now, as you disassemble it, in the first story, you were able to fix just one bearing. In this second story, you have really significant damage to both the rotor of the pump and to the stationary portion or the volute of the pump. And your technician realizes that this is not repairable in-house. The entire pump train has to be sent to a repair shop, potentially scrapped completely, but for sure it's not going to be able to be put right back into operation. Now you have a huge dilemma. You have to procure an entirely new machine train, and not on your own, not in a 4 to 6 week manner, in a comfortable lead time, but like right now the machine train is down. This happened emergently without your awareness in advance, and so you are down until you can find a way to procure a complete replacement. That's a big deal. And as you know, supply chains are getting more difficult, not less difficult, in terms of the lead time for big capital equipment in the modern world, and so this is a really big deal. You are likely going to be down for many months, and if you're not, you're going to pay through the nose to find the one machine train on Earth that actually matches what you need in this particular application. And then final point of the story, when you finally get in your pump train, the machine train is located in the basement of the facility, as pumps often are. And so it's not trivial to get this thing in the door. In order to do this, you need to remove hatches on various floors of the factory and actually use a big external crane that you've had to rent. This is an unusual operation for you. And anytime you're doing unusual operations, the odds of a safety event occurring go up significantly. There is a direct correlation between how trained you are on a particular operation and how likely you are to incur a safety event on that. So in that one quick story, we showed the difference between what life feels like in the predictive maintenance world and what life feels like in the absence of predictive maintenance. And so to tie it all together, let's go through the big 5 ROI savings that you get when you're using predictive maintenance. So number 1 is fairly obvious. Maintenance cost savings. Your maintenance costs go down when you only need to spend a few hours and only need a few inexpensive spare parts to do a repair, rather than replacing the entire machine train, which is what we ended up needing to do. Number 2, capital expenses. This was no longer a maintenance repair. What you did is you had a full-blown capital project for full machine train replacement. That is an unexpected capital budget hit. I am willing to bet that your plant manager will be forced to still hit the original capital budget plan, so something else has to get kicked out of this year's planning. Never ideal, and so we want to reduce, not increase, the amount of capital spend that we have. Number 3 is energy savings. Obviously, the worse that pump got, the more energy it was drawing, and so even if you don't happen to be tracking something like energy within your predictive maintenance program, the simple fact that you are finding and fixing problems in advance will lead to less energy consumption from your overall machinery base. So energy savings are a very real thing, even if you're not directly measuring things like power and power quality being drawn by your machines. Simply doing predictive maintenance will help you. On safety, we saw that anytime you have a machine go through a catastrophic failure, there's actually 2 big safety risks. Number 1, God forbid, the machine catastrophically fails and throws steel in all directions inside of the plant. That is a very obvious personnel safety risk. But the less obvious one is when you replace the full machine train, it's an operation you haven't done before, involving really significant equipment like an external crane that you have to rent. Anytime you're doing complex things that you've never done before, the safety risk goes up, plain and simple. And finally, environmental. When a machine catastrophically fails, that is the most common time to experience environmental spills that you would not have otherwise had and are always going to be EPA reportable. So those are the big 5. The reason we love predictive maintenance so much is because it hits all 5 of those value benefits. And so when you're making your ROI, please include all of those in order to get a predictive maintenance program off the floor at your plant. Thanks for listening. If you enjoyed the content, as always, we love your likes and subscribes, and we'll see you next time.